Yes, let's try to solve this problem, this numerical problem, based on the concept of mole and the limiting reagent. The limiting reagent in a chemical reaction. So what the question is saying is that we have 50.0 kilogram of nitrogen gas and 10.0 kilogram of the hydrogen gas are mixed to produce ammonia NH3 gas. Calculate the amount of ammonia produced or ammonia formed and identify the limiting agent in the production of ammonia. Which of the following two reactants act as a limiting agent and which limits the production of the formation of ammonia? You have to identify that, and you have to find out how much ammonia will be formed if you are supplied with 50 kg of nitrogen and 10.0 kg of hydrogen. Yes, so we write the chemical reaction. Nitrogen gas plus hydrogen gas gives out ammonia. We're writing this symbol, which means that ammonia and hydrogen combines to form, sorry, nitrogen and hydrogen combines to form ammonia, and maybe ammonia will decompose and it will back and it will the reaction might be reversed and form nitrogen hydrogen. That this we will learn in some another chapter, but for the timing these are reactants and these are products, and this equation and this symbol, particular symbol, means that there is a possibility that ammonia may also decompose and form these two elements. Let that be another that will be discussed in some another video. For the timing, let's consider let's balance the chemical equation. We need to, the nitrogen atoms are, I think, okay, the nitrogen atom is not balanced. There are two nitrogen atoms, there is only one, so we just put a coefficient 2. So when it becomes 2 nitrogen, the nitrogen atom is balanced. Now what about hydrogen atom? When we put two coefficient here, the number of hydrogen atom becomes 2 3s are 6. So we have only 2, so we have only 2 hydrogen atom here, so to make it 6, we put 3 coefficients, so 3 2s are 6. Now both the hydrogen atoms and the nitrogen atoms are balanced. Balance means the number of atoms on the left hand side is equal to the number of atoms on the right hand side. That means the mass is conserved, number of atoms are conserved, the mass is conserved according to law of conservation of mass of chemical combination. Now, it says, what does it mean? It means that here we have one mole of nitrogen combines with 3 moles of hydrogen and to give 2 moles of ammonia. So what is mole? It's just numbers, right? One 6.022 into 10 to the power 23 molecules of nitrogen combines with 3 into 6, 3 multiplied by 6.022 into 10 to the power 23 molecules of hydrogen to give 2 moles, means 2 multiplied by 6, 2 times 6.022 into 10 to the power 23 molecules of ammonia. So that is the number. But what we need is, we need to calculate um, in terms of weight. No, we are not concerned about the moles. We're not concerned about the numbers. We are more concerned about the mass of the reactants and the products that we form. So converting these into mass, what we'll get. So 1 mole of nitrogen, how much it will weigh? Nitrogen has atomic number 7, so its atomic mass is double of it. It's not a rule. It's not. There's nothing like rule like that. But generally, the atomic mass is double the atomic number in most of the cases, or approximately to that. So nitrogen is atomic mass 14 U. So it's also, there are two nitrogen atoms, means 4 and means 28 U. So molar mass will be just 28 with the unit gram, 28 gram. So 1 mole of nitrogen weighs 28 gram, and 1 mole of hydrogen atomic mass is 1. So two atoms means 2U. 2U, that means 2 gram, but we have 3 moles, so 3 multiplied by 2 is 6 gram. So 3 moles of hydrogen, 1 mole of hydrogen will weigh 2 gram, but since there are 3 moles, it will be 3 gram, 2 gram into 3, that is 2 gram multiplied by 3, that is 6 gram. And here, what about ammonia? Nitrogen 14, 14 plus 3, 17, 17 multiplied by 2 is 34. So 34 gram of ammonia. 1 mole of ammonia is how much? Only 17 gram, right? But there are 2 moles, so it will be 34 gram multiplied by 34 gram. So what we have in the picture now, how much ammonia will be formed? It depends on what is the limiting agent here, because we are not providing the amount that is required as per the as per the as per the as per the chemical as per the balance calculation. 28 gram of nitrogen is required for 6 gram of hydrogen, or 6 gram of hydrogen requires 28 gram of nitrogen, and they will react completely, and everything will be product, giving rise to 34 gram of ammonia. That means 6, let's see the ratio. What is the ratio of the nitrogen and hydrogen that combines? 6 for the 4 times, 6 4s are 24, 6 4s are 24, 6 5 are 30. It's around 5 times, 6 5 are 6 5 30. A little less than 5 times. And it requires, hydrogen requires little less than 5 times of its weight of its weight of nitrogen, right? But here, what do you see? 10 is 15. 10 kilogram of hydrogen, 50 kg of nitrogen. That means, okay, I'm saying this statement once again. 6 4s are 24, 6 5 are 30. This is not 30, this is little less than 30. 28 gram. So for every 6 gram of hydrogen, amount of nitrogen required is little less than 5 times. 6 5 are 30, little less than 30, right? So this, like, 5 is to 1 is to 5, not 1 is to 5, exactly 1 is to little less than 5. So 5 times of 10 is how much? 50, but it will be little less than 50 that is required for 10 kg of hydrogen. But we have 50 kg, which is exactly 5 times. So I think nitrogen is present in more amount than required. So all the hydrogen will be used up. A little bit nitrogen will be left out. That means the reaction, how much ammonia will be formed, is controlled by hydrogen, because it is present little lesser than what is required, right? So hydrogen is the limiting agent here, because amount of 10 kg of 10 kg of hydrogen 6 kg of hydrogen requires 5 times, little less than 5 times of its weight. So 10 kg of hydrogen means 10 5 is 50, little less than 50, but it is exactly 50. So I mean, ammonia and nitrogen is present in more amount. So how much ammonia will form? It depends on amount of hydrogen. So hydrogen is the limiting reagent. Fine. So how much ammonia will form? It depends on hydrogen, because hydrogen is the limiting. This is what the second part of the question says. Identify the limiting agent. So here in this particular situation, according to the given mass of the two reactants, hydrogen is a limiting reagent. Limiting reagent. That means that the amount of ammonia formed will depend on the quantity of the hydrogen. So now we will calculate how, by using 10 gram of hydrogen. Little bit this will left out. Completely using 10 gram of 10 kg of hydrogen, how much ammonia will produce? Right? This will be a very simple equation. Now 6 gram produces 34 gram of 6 gram of hydrogen produces 34 gram of ammonia. So 6 kg will produce 34 kg, right? Then 10 kg will produce. This is the simple unitary method. 1 kg will produce, say, 34 by 6. So 10 kg multiplied by 10. That means 34 by 6 multiplied by 10, which comes to 56.6 kg. Yeah. So 6 kg of 10 kg of hydrogen will produce ultimately 56.6 kg of ammonia. This can be calculated. This you can see from here. 6 6 or 36. Around 6 times. This is around 6 times hydrogen's weight mass. Ammonia's mass is around, as per the equation, the amount of ammonia formed will be around 6 times of this. So 6 gram, 6 6 or 30, little less than 6 times. So 10 kg, 6 times 10 6 is 60, little less than 6 kg. That is 56.6 kg. So I think our answer is approximately like right. And what about the point? Actually, if you divide 170 by 3, it's like 56.666666. But how many, after decimal, how many 6 you will put, or you will consider? And it depends on the idea of the scientific notation. No, it depends on the number of significant figures. See, 50.0, it means that there are 3 significant figures. Here are also 3 significant figures. So whatever calculation you do, multiplication or division, the final answer, the final product, the final result should have 3 significant figures. So I have considered 3 significant figures. 56.6 actually it should be one more 6, so rounding off it will 56.7 kg. So this will be the right answer.